First of all, my name is Mo Goyle. I'm the product manager of marketing, my childhood changes all the time here. Director of product marketing at Evertz. I was also the co-chair for the Aspen community. Unfortunately, he is gone. Rich, can you grab him? Because some of the presentations are cropped out there. So just to give you an update where we are with the Aspen community, it's been growing significantly since we introduced it at IBC at 2015. We actually have one of the partners here, a few partners here. And really the big thing about it is we've had a couple of big objectives for the community. One, and first and foremost, was really to get the publication of SMPTE RDD, Registration Disclosure Document 37, into SMPTE and have it into the public domain. So what this does, and this was achieved in March of last month, essentially puts it into the public domain where it's an open format, which anybody in the community, anybody in the SMPTE group can go ahead and take that document and implement Aspen. So what this allows us to do is really build on really the second major objective, which is interoperability. And that's really where the customer base, anybody who's deploying IP today, is looking for an open format and something that is interoperable across multiple vendors. Just like we do with SDI today, I can plug in SDI from any device, from any cabling manufacturer to any switch manufacturer to any router. I want, and the customer wants to have that same kind of feel, right? They expect that. And really that was two objectives that we were going with when we developed or when we formed the community, is the open format as well as the interoperability. So this year, one of the things that we're doing is we actually have a booth in the North Hall that is going to promote some of that interoperability with some of our partners. So amongst that, we'll have a booth that's located in North Hall, but you can see a number of our members throughout the North, Central, and South Halls. The booth itself will have presentations, actually participating members that have interoperable demonstrations, moving video across the switch fabric. So having some of the equipment is going to be Abacus, Embryonics, ourselves Evertz, Hitachi, Matrox, PacketStorm, Ross, Sony, Tektronix, and VizRT. So these are all, they're going to have different devices that will be connecting into an IP core using Aspen. We had a couple more members, and unfortunately for time's sake, sometimes when you really are pushing the cutting edge, it's tough to get into the trade show. But we have many more partners actively working on product right now that supports Aspen. So some of the key products there from Matrox will be their XMAO3. So again, it's a 10 gig IO that's going to be outputting Aspen interfacing. So it basically takes Aspen streams as well as outputs it. So they're partnering up in their demonstration with VizRT. So this module fits into their device that will then take graphics into the IP core. Another one is Abacus. They're going to have a player, so they're going to have a device that's actually going to stream content using Aspen into the IP core that they can then also capture. One of the big announcements we made at IBC is going to be working with Ross. So Ross is going to have a production switcher that will have native IP interfaces onto it, which will be Aspen enabled. So we're actually going to take some of those signals that we've got from cameras and such, feeding into there with the graphics input as well. Capture and replay system by Tektronix, that's going to help us capture. So these are some of the tools that you're going to need to develop, or you're going to have as you look into the IP space, what the packet types are and how to troubleshoot things. And these are some of the tools that are going to be available. A couple other ones, Tektronix will have their Prism. So this is going to be their hybrid IP SDI media analyzer, as well as Sony's going to have their gateways that support NMI as well as Aspen on the device. So these are the gateways that they'll have on the cameras and the production switchers. So again, working through the partnership we've had with them for a year now, adding the Aspen feature set onto their cameras and switches that are IP enabled. Embryonics will be announcing their video SFPs that they'll be able to plug into SFP enabled devices that will support SMPTE standards as well as Aspen And of course, we'll be having our gateways, our packet switch and control system, basically moving the video signals in and around the demonstration there. So that's kind of the quick Aspen community update. Again, we're excited about it. This is going to be a very, I think, powerful message that we're going to have to show the industry of the interoperability that's happening within it, the partnerships that are happening amongst the members, that customers now have a complete system that they can go and move to IP. And I'm going to introduce Michael Cormet from NewTek, who's one of our newer members, and to give a kind of a point of view as to why they joined the Aspen community.
Great. Hi, everyone. So, first of all, we're thrilled to be here. Thank you, Mo, for that. And just a quick note about NewTek, if some of you hopefully know about NewTek, but the mission is really just to bring, give storytellers a voice through video, and that's what we're about. We certainly have products and customers at the high end of the broadcast tier, but one of the things that makes us unique is that we bring customers into the market that don't do broadcasting for a living, but want to do broadcast quality productions, and so we're bringing new people into the market every month. It's really one of the sweet spots of NewTek that we bring to the table. And we've also created something called NDI. And Andrew Cross and his team have been working on this actually for about 11 years. When we first created TriCaster, we had an application that allowed PowerPoints to come into the TriCaster through something we called IBGA Pro, and it was to get it into through the Ethernet port. We then, a few years later, opened that up to our developer network, made it part of our SDK, and a lot of companies and manufacturers provided their integration with their devices and applications through the Ethernet port with our technology. And so we decided, if we recognize that IP is actually one of the biggest things in our broadcast careers that we're going to see. Some of us have been in the business for 10, 20, 30 years, and over that time span, there's only going to be, we think, a handful of things that are this fundamental in the way that they change workflow. And if that's the case, we felt like we needed to open up this technology to everyone. And so that's what NDI is. And one of the nice things about it is that, with the internet, you can exist side by side with other standards. And so it was a no-brainer for us to join Aspen, and a huge benefit, I think, for customers. This is a special moment in time, I think, when we look back at this, because NDI and Aspen are going to be in the same workflow for many customers, and we think that's a huge boon for the industry.
All right, so this year, our biggest focuses, the 4 areas that we're going to focus on this year are going to be IP in the facility, and that's something that, again, that's going to be a big thing in the industry for the show. 4K HDR, how do we handle that? What do we do to build a facility around supporting that format? Cloud services, kind of the really next step for the industry is to embrace cloud services, which then leads into the facility 2020. What's the facility going to look like 5 years from now, or 4 to 5 years from now? Right? It's going to change significantly now that we've moved. We really have seen this uptake in the transition to IP. So let's first start off talk about IP in the facility. Again, we've been deploying our SDVN solution for about 3 to 4 years. It's been an exciting adventure for the company. We've had a very strong deployment of this system. A number of major broadcasters from across the industry have adopted the technology. Fox is one of them that we kind of did a press release earlier this week. We've also got NBC Sports, ESPN, and a few others that have already deployed this technology. So the technology itself, in terms of the embracement of IP, has already begun. It's not something that is an approach that's kind of been taken on a very cautious path. We've had a lot of them now adopt, a lot of the major broadcasters adopt it simply because they see the enormous benefits of moving to IP. Our portfolio includes a significant amount of all the pieces that you would need to move IP and video signals over IP within the facility. So a number of gateways, we have a control system, the switch fabrics, and a series of different pooled resources. And again, these are products that have been going through for the last couple of years. And really we're going to keep on focusing on the technology here because it is been deployed. We've learned a lot from those deployments, whether it's a production environment, whether it's a playout environment, whether it's a head-end type of application. they all have different types of needs. And the way we built the system, the way that they control the system is really where the value add is in our solution. And a lot of our focus is going to be on the control system and the switch fabric, the capacity, capabilities of the switch fabric, which is our EXC family, as well as the control system, which is Magnum. Magnum, the control system, has been used in the SDI world, and we've added modules to it that allow us to migrate to the IP space very easily. Now, one of the big things that's sort of a topic, and this kind of addresses the earlier question here, is the industry is looking for this open format, open standard, like they are for that SDI. And one of the big things here is that we've been a member of all these different groups that have been working on the technical side for moving uncompressed video over IP. Okay. And we've been actively participating. One of the things that we did was when we looked at how do we do it 3 years ago in getting it to market and getting it into customers who had an immediate need for IP, we looked at it saying, well, let's leverage technology that we have today. And that's really where Aspen came out of, is take the existing MPEG-2 ecosystem that the industry is quite familiar with. They used to bring signals into the facility. They take signals out of the facility over TS. It's not going to go anywhere anytime. So it was an opportunity to now add and expand on that existing infrastructure. And that's really where Aspen kind of came out of, building off of that standard that was defined already for MPEG-2, adding on to the uncompressed component, and then we took it to something we published in. At the same time, we've joined a number of different alliances or groups. And the question becomes why? Well, the reality is we're at that point where there's a lot of things happening. And as Michael pointed out, as we have different segments of the market, different technologies apply. And really what the industry is looking for is a harmonization. And that's really one of the reasons why we joined AIMS, is that it's about deriving a harmonization for those companies that already exist with the technology today and allowing them to have that roadmap to move to something that gets finalized. What we have in SMPTE today is not going to be finalized just yet. It still has to go through some iteration and some different processes and to test it against different use cases. But this is where we want to make sure that our customers are very comfortable with making a decision today on technology they can buy today and having that clear path to move forward. So that's really where, when we look at this harmonization, is looking at those that have been developed in Aspen and able to migrate to whatever new format or whatever we standardize in the industry very easily. So they're not preventing themselves from making that business decision today. They can make that business decision today very confidently to move forward. Okay. And that's the same thing with NDI. Again, as Michael talked about, it's a different entity of the industry. They've been using it for a while. And again, to be able to provide that bridge between NDI and Aspen and whatever the harmonized format is going to be enormous for the industry, because different aspects require different things. And this really just kind of puts everything into that same path to something that everyone can use confidently and define or meets their needs of openness and interoperability. So that's really one of the driving factors behind becoming a member of all these different groups, is that we understand that there's a lot of things happening, a lot of very dynamic, agile things, and we're trying to get everything back onto the same path of everyone can be on the, checking the right format or picking a standard that works for everyone. So, in terms of what's new within our IP infrastructure, a few little products here. We've got our IP gateway card that fits into the EQX. So this is, again, a companion to the input card that we put out there a couple of years ago. Allows us to transition to IP very easily with existing EQXs. So our EQXs are SDI routers that have been deployed in numerous facilities. Again, providing a gateway for our customers to move to IP at their own pace without having to rebuild their infrastructure. And this module fits right into the chassis for existing EQXs that have been shipping for the last 7 years to anything that we shipped yesterday or on Friday. You can use this module and plug it in. And what it does is allows us to take that SDI, encapsulate it over IP, whether it's 2022-6, whether it's Aspen, or TR03 of a iteration, whatever iteration comes out. You can take that and feed that into an IPX. Feed into the EXE core and have that transition into IP very easily. Another platform we're introducing is what we call EV Edge. This is kind of a software-defined computing and routing platform. So this allows us to get higher density now, What we're starting to see is demands for larger packet switches. So this gives us the possibility or capability of adding a 128 port IPX card that we've got, which is our smaller switch fabrics. Gives us the capability of increasing the density for gateways. So as more signals need to be converted from one format to IP, we can do that through this processing platform. The other big thing is the edge compute blades, and I'll dig into that a little bit further on, but what this does, it allows us to get away from dedicated hardware for fixed functionality. What it does allows us to move to something that's more virtualized, where I can spin up processes, whether it's conversion, procking, multi-viewing, when I need it. So instead of having a customer and go and buy different pieces of dedicated hardware and only using it for certain times, this gives them that flexibility to use it on demand, essentially. So it changes the dynamic for the customers because it really changes how they build and operate their system. And because it gives them a great deal of elasticity and agility because it can scale their system up and down based on their needs. The 57 MSC, it's our IP master clock. So this gives us, again, another tool to bridge that gap between baseband and IP. So we still have this enormous amount of footprint with SDI. We're gonna need blackburst, we're gonna need tri-level support. But with this device, we can also then have a timing plane that we can use for IP, whether it's IEEE 1588 or SMPTE 2059-2 and such. So that gives us the capability of having that hybrid architecture of SDI and IP and having a timing mechanism to handle that SDI and IP. You also have a test signal generator that will be using over 10 gig Ethernet. So today it's Aspen. We'll have support for 2022-6 as well as TR03. Insight, this is probably the biggest announcement we'll have. It's basically allowing our customers to have a little bit more operational intelligence on what's going on in their system. So the biggest challenge as systems grow, whether it was SDI or even now to IP, is understanding what's happening in your system, understanding what's going on, and collecting all those different sources of logs if there's troubles, and trying to stitch together the event that caused the failure, or looking at what's the process or the performance of your system. So what this is essentially a data analytics collector. So it collects all types of information coming in from the system. And what it does, it collects that information and then allows the customer to generate various reports based on what they want to know about the system. So essentially what the functional overview is this. Systems are connected to the network, and inside it collects all the different types of data that's coming through. It collects it as syslog, it takes it as SNMP, JSON, unstructured data, IP. It's essentially a collector of data. And on the other side is basically what I do with that data. What does the end user do with that data? For the most part, they look at it from a troubleshooting perspective. We had a signal go down. What happened? Who did it? When did they do it? And I can rewind back to find out that event and connect all the different pieces that form that event, whether it was a gateway card, a conversion, a routing switch, fabric, maybe it was a transcoder that went down in the cloud. I can track it all and drill down and help our customers troubleshoot their system a lot more effectively. The other part is I can start looking at utilization as we move into IP. What are my devices? Do I need to add more up converters? Do I need to add more other elements into the system? It gives me a trend of analysis so I can see the usage of my system and see where there's opportunities to make it more efficient or opportunities to add more resources to it. So there's things like event correlation, statistics, predictable notification, logical event, a whole bunch of different capabilities. But the best way to show you is, here's an example. So this is a system that we've been running on our booth as we're setting up. So I did a snap of a signal moving from our gateway card into our switch fabric and out to another gateway card. And this was, let's say, taken last night at about 10 o'clock. I could then say, okay, well, let's see what the system looked like 3 hours ago when we were all running and doing a bunch of things. Well, I can click back and then look at the system, what it looked like 3 hours ago. So what this does, it gives me a view of how taxed my system was three years ago. It gives me an insight of what's happening at that point. So if I have elements where, well, we're hammering that gateway card, we may want to shift some of that signals out because we may be doing a large event, we can quickly identify that. Or if there's a trouble, or if there was an incident, we can troubleshoot that very quickly. So that's the kind of information that we're collecting and displaying for our customers. So really it helps them use the terminology or use big data to derive information about what's going on in their system. And again, as we present this to customers, they are seeing other applications for this. For them, it's once they get that data, how they utilize that data is going to be very powerful for them. UHD, HDR is going to be a big topic. Again, we have different solutions there. We understand that, that 4K is coming. We've seen an enormous uptake in the 4K deployments. We have a number of channels going up, and they're increasing every day. So we have different choices. For those that want to do quad link, we have a series of different products and offer them to do quad link. We have things like carrying it over fiber, or VBA transport. So moving signals from a remote site over a SONET network or SDH network, you can use this device, using 40 gig links in this case as well. Something like a clean switch, so the ability to have multiple 4K signals going in with a built-in frame sync, so I can time the lanes as they come in, and having the ability to have a frame sync. So I can do clean switch capabilities in this, so that, if there's an error, I can switch to another feed. Again, support for both SQD, or square quadrant division, and to SI is on this module. Up converters. So again, as we make that transition, just like we did when we went from SD to HD, we're going to have to leverage this wide library of HD content into the 4K chain. So products like this one here is going to be very important, because I can leverage my existing HD content, up convert it into a 4K chain very easily. And a number of facilities already launching their 4K services using this product. 4K playout. So this is our mediator interface into our 4K channel, our integrated Overture RT Live UHD for channel playout with 4K, with HDR support. It's going to be a big product that we're introducing here with the HDR capabilities. We have secured a couple of major broadcasters. Unfortunately, I can't announce who they are, but they are using this for their 4K services. Dreamcatcher, again, one of the big things about Dreamcatcher has always been 4K. When we introduced Dreamcatcher about 4 years ago, it was specifically, one of the opportunities we saw was doing 4K replay. Well, we've added more feature sets to here. We're giving the scalability to now have multiple 4K channels. So I can build a system that has multiple cameras into the chassis or into the platform. We support high dynamic range as well as high frame rate. So as the sports production teams look at using 4K, not only just HDR, but also high frame rates of 104 times, 5 times as much. Some of the camera manufacturers are going to be demonstrating that this year. So the ability to capture that information and provide a replay system is very important. 12 gig SDI. So we've got a lot of interest in 12 gig SDI from a lot of international customers. As they are slowly making their transition to IP, they still have this the conservative approach of, well, we still want a single cable. We still want to reside in an SDI world. 12 gig gives them that capability of migrating to support 4K, but still staying in the SDI world. And we've addressed that with a number of different products here, whether it's our routers, our new DAs, our new converters, as well as our converters. Okay. So helping our international market make that support 4K while still residing in the SDI world. One of the interesting cards here is the ability to support quad link to 12 gig and 12 gig to quad link. What's becoming evident is there is a limited amount of products that have native 12 gig I/O, but there's a number of products that have 4 lanes. So we can take the quad link, put it into a 12 gig, feed it through a 12 gig router, and have that ability to bridge the 4 quad links to, or the quad link 3 gig to a single 12 gig SDI cable very easily. SFPs, this is again a way to carry 12 gig over optical for optical distribution. So it takes it uncompressed over fiber, carries it across. So it's a simple O to E, E to O conversion, electrical to optical, optical to electrical conversion. Again, for facilities that want to move 4K through just carrying over an optical network. And then we talk about carrying it over IP. So one of the big things here is that we're also starting to see this discussion about what compression format to take. We have discussions about J2K, we have TICO, we have Sony's low latency video codec, we have VC2 out there, so a number of different compressions, which is adding to a bit of the confusion as to what's the right one to go. What we start to see now is really the most prudent approach is going to be to move to uncompressed. Uncompressed allows us to really simplify how we what our workflow is. So we can leverage any CAMI manufacturer, any production switch. We're not restricted by the compression format to choose a particular vendor. Here, by moving to uncompressed, we're making it very easy. We're also removing the complexity of the compression systems, of moving between different compression formats, adding this additional delay into that production. So, with this system, you're talking about lines of delay where by adding some of the compression, you could add frames of delay, which is not good for the system altogether. So in this case, we'll be distributing a number of 4K signals throughout our booth as uncompressed to highlight the capabilities of the fact you can do this and still do clean switching and such. So there's a few different ways of how we carry it, and we use Aspen to do so. We also have a Sony NMI, so we're showing a Sony NMI. So this is using the compressed format as an example of it. It doesn't matter from our perspective. You still can do compressed. You can use JPEG 2000. You can use LVC, but we see that the industry really will start migrating to an uncompressed format very shortly. Cloud services. So this is a big one for us as well, because in this case we've partnered up with Amazon Web Services to display how we can take channel playout that would reside in the company or your customer's premise to something that would reside on the cloud. So essentially leveraging our asset management system called Mediator X, as well as our Overture RT Live, which is our integrated channel playout, we're actually going to have on the booth a channel that is basically playing out of Amazon's cloud. So essentially we're going to take a live feed from the Las Vegas show floor. We actually carry that over IP into the cloud. We have content stored in the cloud that we're going to actually transition and go back through. We actually have a feed from Burlington that's also going to be transitioned. So we're going to show live to live, stored to live transitions, all running through Amazon's web services. And this is a quite appealing story to a number of media companies, because they're looking at ways to cost reduce the cost of putting out channels. And this gives them a capability of running those channels in the cloud without having to invest in a lot of hardware on premise. Okay. So what this does is I can do two things. I can create a private cloud, so still have elements within my facility, but running it on off-the-shelf IT servers and such. Or I can move to the public cloud, where all those different elements are sitting in the cloud services provided by, for example, AWS or Microsoft Azure, or what other cloud providers that may be there. And this again gives me a couple different options of creating not only disaster recovery or having disaster recovery for some of my main services, but also short-term channels. So for example, with the Olympics coming up, this is a great way for media companies to launch those temporary channels without having to invest in the hardware to do so. So again, this is what we're showing here as a live stream coming in from Burlington, as well as switching and transitioning between services in the cloud itself. The interfacing into the system isn't going to change, so this is Mediator X creating not only our linear playout, but also spinning off nonlinear assets in the cloud. So as I'm driving content, I'm delivering it through the linear channel, but also the nonlinear devices, whether it's the OTT services that they want to provide, or streaming elements within their own local services and such. So this gives them the ability to not only handle their linear, but their non-linear distribution through the cloud as well. And the interface to them doesn't change on how they interface or how they access the system. Lastly, the introduction of Facility 2020, the software-defined data center for broadcasters. And this is really where we see the industry moving next, right? As we move to IP, we start changing the dynamics of how we work. We no longer look at things in a linear manner, we look at things in a non-linear manner. So I need a resource, I make a software connection, pull up the up converter, bring it into path. When I'm done with it, I free it back up. So today, as companies are moving to IP, they're now enabling themselves to look at resources in a different manner. Rather than dedicating a resource to a particular service, I can put them in a pool and call them up when I need them. Today, that would be a bank of physical hardware, like up converters, physical bank of hardware, so multi-viewers, physical bank of hardware of playout engines and such. And these would be devices that they have. Now that they've gone to IP, they can look at other ways of simplifying those pooled resources. So what we're introducing now is our video processing platform. And what this enables us to do is, instead of having dedicated hardware doing specific functionality, I can create blades that allow me to spin up services when I need it. And I kind of talked about that a little bit earlier. And what that does, it gives our companies or customers agility, efficiency, and adaptability. for doing things. So what does that mean? Well, EV Edge becomes a very big part of that, because what this is, it allows us to have these compute blades. These are blades that have programmable FPGAs. So what happens is I put in a bunch of these blades, and I can say I want to provision 5 up conversions on that blade today. Maybe the next day I want to spin off 5 multiviewers on that blade. That blade is no longer a specific functional block, it becomes a very dynamic, and I essentially license services on it to allow me to do different processes. So what it looks like now is, instead of having those banks of individual hardware elements, I have banks of compute blades. Or I have a private cloud using enterprise hardware to do that. Or I can even spin it off into the cloud. Okay, so again, now we're looking at processes that we use dedicated hardware, now becoming virtualized. So it really, again, changes the dynamic of how a facility gets built and the infrastructure that is now bought by our customers. So these are the different resources that can be pooled, whether it's video, audio, VANC, gateways, or multiviewers. These are all different processes that can be spun up or spun down based on needs. Okay, and so what a customer can do is bring in a schedule that can configure a production room for what resources they need for that time of day. And then they can spin it down, spin up those same resources for another production control room when they need it. Okay, so it gives them a great deal of flexibility and agility to do things. So what this looks like is, for example, here we've got our interface, that's our IRM, our Intelligent Resource Manager. So typically that would have been a signal coming in, baseband, that would have been a dedicated hardware element that I would have scheduled, and that would have gone into an SDI world. Here is essentially an IP signal that comes in. We have the service that we basically spins up. So in this case, we wanted to spin up a video procking capabilities. So what this does, it goes into the pool, spins up that video proc. We use that video proc for the time, for as long as we need it, and then we free it back into the pool. And that becomes available for some other process later, or for some other services later on. Here's another example of that. So in this case, it's basically the license manager. So you've got different processes that are available that you can license. So what this does is changes how the purchasing is done within a facility. They may have a bank of dedicated licenses that they will use, and then they'll have ones that they'll use when they need it. And so again, it's a shift in the way that the industry will approach building the facility. And again, it becomes more of an on-demand rather than just a dedicated hardware. And again, Insight collects that information. So not only are we collecting information about from the different devices, we're also capturing how many times the service is spun up, how many times it's spun down. So that allows us to create a billing model very easily as well. So that's part of the data analytics you're collecting, to be able to track the successes of the processes, or the usage of the processes. One of the big things about Dreamcatcher is we really are shifting the way we approach Dreamcatcher. And this kind of ties into the Facility 2020 as well. So we always think about Dreamcatcher as a box, and that's really kind of a misnomer. We look at it as a platform, and a platform that has a series of different processes, whether that's an encode, decode, record, database, view, or plan. Okay? And typically what happens is when we network these devices together over a 10 gig network, it becomes a cluster of nodes. And what these nodes have different capabilities. Now, what this flexibility does, instead of looking at it as a device that has fixed processes, we look at it as a platform that can be reshifted any way we want. Okay? And in fact, this is the model that we're using, and we've been using for the last 2 years at the NBA. So what happens now is the NBA Replay Center is really a collection of Dreamcatcher platforms, or Dreamcatcher nodes. And they spin up services when they need it based on the game schedule. So when there's games where they only have 1 or 2 that they're going to be officiating, they will only spin off a few of those different services. They can scale the system to handle the full slate of games on any given night. So the system contracts or scales based on their needs. And now what they're doing with this is they're now realizing some of the other functions they can do with this capability. So they're now driving other capabilities, like spinning out other material from this capability, because when the system's not being used during the night, during the evening, during the day, they're spinning it up doing other processes. So it's that kind of virtualization, that kind of dynamic, agile environment, that's really, we've been doing for a couple of years already with the NBA, we're now bringing it into the facility. And it's all being controlled and managed by Magnum. Again, that control system, that orchestration layer, pulling the pieces together, bringing the game schedule in, bringing any type of schedule in, and allocating the resources for that particular service, and then freeing them up afterwards.